take just a few minutes to talk to you about developing addition algorithms. Over 15 years of doing this with students, I've learned that there are a couple things that can help make this transition of solving problems vertically using our understanding of place value go much smoother, and I wanted to share some of those things with you. Now, whether you're adding 2-digit numbers in first grade or you're adding 5- and 6-digit numbers in 4th and 5th grade, this video applies to all of those because it's about taking the understanding and helping students connect from concrete materials to the vertical algorithm. So I'm going to start with a 2-digit number, but I want to remind you that this applies to all the numbers, and whether you're using base 10 blocks or place value chips, you can use these things with your students. So we're going to start with a 2-digit number without regrouping. So let's say we wanted to add 32 and 14. Well, we start in the concrete with our kids because we want to make sure that they know what that means. So I'm going to represent it here in my place value chart. And then I'm going to ask students to tell me, what's the total? And how would you find the total? What would you do? And what we typically see our students do with the concrete, they have no issue with this. They just bump it up, right? They move these up and then they give you an answer. Simple. But then we go here and we're trying to teach our students that there are these types of algorithms that can help us compute the answer quickly. But what happens a lot of times is we start listing a bunch of rules they have to follow, and kids forget rules. I don't know about you, but my kids always forget the rules, and we have to come back and we have to talk about them. So instead of teaching them a series of rules or steps or procedures, we can root it in meaning. So one of the first things that I want to point out, what we did when we moved these. Did I move them in any specific order? I actually started in the tens. I don't know if anybody noticed that. When we're adding numbers without regrouping or renaming, you don't have to start in the ones column. So a lot of times what happens is we start here and we tell kids always start in the ones. Well, then they move to decimals and they start in the tenths or the hundredths, and now we're teaching them something that may have not been true. So instead of saying always start in the ones, I always ask kids, start where it makes sense. So let's look here. When you're combining these, it really didn't matter what order you went in because you combined tens and tens and ones and ones. That's the most important part. So when I look here, I see ones and ones, 2 ones, and 4 ones is 6 ones, and 3 tens and 1 10 is 4 tens. So my answer is 46, and it matches here. Could I have added tens first? Sure. 3 tens and 1 tens is still going to be 4 tens, and 2 ones and 4 ones is still going to be 6 ones. So that didn't matter. So what happens when we actually have to start in the ones place because we have renaming? How are we going to help our students do that? Now again, we can use the concrete and the algorithm to help them make sense of this. And I'm going to do a 2-digit number. So even if you're working in 5 and 6 digits, that's okay. Let's see how this connects. So let's say I wanted to add 34 and let's do 28. Now, one of the first things I ask students to do is to look at it and see if they notice any numbers that might be greater than 9 when they are combined. So we're actually going to represent it with our base 10 blocks first. So we have it. And we're going to put all our pieces out together. And I'm going to ask students, do you see anything that when we add them together, they are going to be greater than 9? Now, why does that matter? Well, we've learned in place value, when you're recording your digits, you want 1 digit in each place because that's going to help us record the number. So when I'm working in the vertical algorithm, it's really hard to put 2 digits here because that's the ones place. It only gets 1 digit. So I can already tell by looking at 28 that I only need 2 more ones and I'm going to be at 10. And I know that there's more than 2 ones here. So first of all, I want students to just turn on that little activation. Be ready for it. Be prepared for it. I do that with 5 and 6 digit numbers. I ask students to go ahead and look at them and decide, is there going to be renaming or regrouping? Now, just to point out one difference, because you'll hear that I keep using those terms. Regrouping is the action of physically moving these pieces and exchanging them. Renaming is what you rename it. You rename 10 ones for 1 10. You regroup the physical ones into a 10. Okay, just to make that clear. So now what I'm going to ask our students is, what do you do when you want to add these together? Can you start anywhere? I let them do it. Let them start in the tens place, and then they get here and ooh, something happens. What happens? Oh, I've got to put another 10 here, and then I have to add a 10 again. Well, that's kind of complicated. What if you just started in the ones place or the place of least value, which again prevents that rule, right? So here's the next thing we do. We're going to combine our ones just like we did previously. And what we see happens when we combine our ones is that we have more than 9. We actually have 12. So what we can do is we can rename 10 ones for 1 10. So I'm going to go ahead and take these 10 ones. Now here's the thing, and there goes one flying. You want them to physically take those 10 ones and not pick up that 10 until they've got them in their hands. So you want that physical exchange to happen. So here's my 10 ones, here's my 10. Now here's the other thing I want you to do. I want you to place the 10 on top. Do you know why I want the 10 up top? Because it looks like this. So whenever they rename 10 ones for a 10 or 10 tens for 100 or whatever it is, I always place it on top. Because now when we come over here and we add, we can say 4 ones and 8 ones is 12 ones. And I'm actually going to put it right here. 12 ones can be renamed as 1 10 and 2 ones. Now I make my students write this out when they're learning this because I want to make sure that they are understanding and they're explaining this step. So we're going to record the ones in the ones place. We're going to record that renamed 10 up top. Hey, that looks a lot like my picture. Do you see that? So we're connecting our concrete to this vertical algorithm, and then we would add all our 10s up. So a couple things I want you to take away from this video. Be wary of saying always. Always start in this place, because when you do mental math, we're going to kind of trick them on that and say, oh, we could start in hundreds or tens. And when we start introducing decimals, they're going to start in a different place value. So just be wary of that. The other thing I want to remind you is see how your models can match and point those out to your students. Ask them to look for how they're the same and how they're different. Have your students write out the renaming along the side. Yes, it's tedious, but they do it for a little while so that they carry it with them for a long time. And finally, if you need to, use grid paper to help students align those digits. Help them to see that ones go with ones, tens go with tens, and so on and so forth, so that they're understanding that we are adding each place value, which is similar to what we did with the base 10 blocks. I'm hoping these strategies will help you to make sense of the algorithm when you're moving from the concrete, and I hope that they help students, whether working from 2-digit numbers to 6-digit numbers, add fluently.